You know how it is, right? That new highway, the skyscraper going up downtown, it always seems to take years longer and cost millions more than anyone promised. Well, today we're going to pull back the curtain on the hidden science that's supposed to stop that from happening. It's called cost engineering.
I mean, think about it. It doesn't matter if it's a huge bridge or just the latest app on your phone. Delays and going over budget, it's almost a given, right? So in this explainer, we're going to get to the bottom of why that happens so often, and we'll look at the special field of engineering that was literally created to prevent it.
Okay, so the source material we're looking at here, it makes this really powerful point right from the get-go. A brilliant design for, say, a new building, that's only half the story. It's just an idea, really. To actually build it, you have to nail the management of the money, the time, and all the resources involved. If you don't, well, that brilliant blueprint is just wishful thinking. And that's exactly where our solution comes in. See, to handle all those real-world investments, this whole specialized field of engineering popped up. Its entire focus? Mastering cost, schedule, and risk. And the people who do this? They're the cost engineers. So the big idea they operate on is something called total cost management, or TCM. And that word total is the key here. It's not just about setting a budget at the beginning and hoping for the best. Nope. It's about managing every single cost throughout the entire life of the project, from the first napkin sketch to the day it's torn down. It's like financial oversight for a project from cradle to grave. This is a really cool way to think about it. Every single project has two sides to it, two dimensions. First, you've got the physical dimension, the actual steel beams for a bridge or the lines of code for an app. But then there's this whole other side, the cost dimension. That's all the money, time, and resources you need to pour in to make the physical part happen. And cost engineers, they are the absolute masters of that second dimension. They're the ones who make sure the vision can actually get built in the real world.
Okay, so you might be thinking, do I need a classic engineering degree for this? And honestly, the answer is kind of surprising. The source material says, yeah, an engineering mindset definitely helps, but the door to this field is way wider than you'd probably guess.
It's really a mix of all kinds of experts. You've got people with titles like planner, scheduler, cost estimator, value engineer, a whole bunch of them. The thing that ties them all together isn't a piece of paper, a specific degree. It's a mindset. It's about using science and data to solve really complicated business problems. That's why you see people from finance, from operations, and yeah, from technical fields too, all succeeding as cost engineers.
All right, so if you've got this diverse bunch of people, what's in their toolkit? What do they all need to know to do their job? Let's take a look at the fundamental skills you've got to have to handle that tricky cost dimension.
It basically breaks down into three big pillars of knowledge. First up, you have to understand the elements of cost, the absolute building blocks of any budget. Then, you need the elements of analysis. That's how you use data to make smart calls. And finally, there's what's called enabling knowledge, which is all about managing the people, the information, and the quality to make it all happen.
Let's dig into that a bit. Take something like labor. What's the real cost? It is never just the person's salary. A cost engineer has to think about everything else. We're talking benefits, taxes, insurance, the cost of potential overtime, even fuzzy things like what might affect their productivity. It's a super detailed calculation.
And it's the exact same story with materials. The cost of a pallet of bricks, it's not just the price on the invoice. You've got shipping, handling, taxes, storing them somewhere safe, and a good cost engineer even builds in a buffer for stuff that might get broken, wasted, or even stolen. Every single link in that chain adds to the cost and can totally change the project's final price tag.
And in that analysis toolkit, they're using some pretty powerful economic ideas, like opportunity cost. So what's that? It means the cost of doing something isn't just the money you spend, it's also about the benefits you miss out on from the other thing you could have done. So say a company spends $100 million on a new factory. The opportunity cost is all the profit they might have made if they'd put that same $100 million into, say, building a new app instead. It's a huge deal for making the right strategic decisions.
Okay, so we've got the right people and they've got the right tools. But how does this all come together in the real world? Let's walk through the actual process they use to keep these massive, complex projects from going off the rails. The engine that drives all of this is a really simple but super powerful four-step cycle. It's called plan, do, check, and assess. And the key thing to remember is this isn't a one-and-done kind of thing. It's a continuous loop. You're always planning, doing, checking, and then adjusting over and over again.
Step one, of course, is the plan. And I mean, this is everything. This is the foundation for the entire project. So for that bridge we were talking about, the plan isn't just a drawing. It is a super detailed blueprint for the cost dimension. It lays out exactly what's being built, how long it will take, and what it's going to cost. Scope, schedule, budget, it's all there.
And just to be clear, when we say the plan, we're not talking about one single document. Not at all. It's actually a whole collection of plans that all work together. You've got your scope plan, your detailed schedule, the full budget, and, this is so important, a plan for managing risks before they can blow up the project.
Okay, plan's in place. Now it's time for step 2, do. This is where the rubber meets the road. The crew shows up, construction starts, and the money starts flowing. And for the cost engineer, this is all about tracking every single thing. They're watching the actual costs and the real progress, making sure all that data is captured perfectly.
But hang on. With a million things happening at once, how do you really know if you're on track? I mean, just because you've spent half the money doesn't mean you're halfway finished, right? This is where we get to the check phase. We need a way to measure what's really going on objectively.
And the killer app for this is something called Earned Value Management. The source material really singles this out as a game changer for measuring progress. Instead of just looking at the bills, it does something brilliant. It links together the plan, what you've actually spent, and, here's the magic, how much physical work you have actually gotten done. It all comes down to 3 numbers. You've got planned value, or PV, that's the budget for the work you were supposed to do by now. Then there's actual cost, AC, that's what you've really spent. And the secret sauce is earned value, EV, that's the budget for the work you've actually finished. By comparing these, you get an instant health check. Is your EV lower than your PV? Boom, you're behind schedule. Is your EV lower than your AC? Uh-oh, you're over budget. It's like a dashboard for your entire project.
And that brings us to the last step, assess. This is where all that data turns into action. The cost engineer looks at the trends and figures out where the project is headed. If things are going south, behind schedule, over budget, they dig in to find out why. Then they recommend specific fixes to get things back on track. And once they do that, the whole cycle, plan, do, check, assess, it starts all over again.
So, in the end, it's not about getting lucky. It's not even just about working harder. As the source material puts it, success comes from being systematic. When you professionally manage that cost dimension, and that's the whole job of a cost engineer, that's what makes the difference between success and failure.
So, hey, the next time you're driving over a bridge or opening up a new app on your phone, take a second to think about the invisible work that went into it. Behind that big idea, there was a cost engineer wrestling with all the risks to turn that vision into a real thing. Hopefully on time and on budget. It kind of makes you wonder, doesn't it? What other things all around us have this hidden cost dimension that we never even think about?